Here's a single sheet of polarizer, a kind of filter that lets through only electric field vibrations that are in a certain direction called the transmission axis. I've marked the transmission axis on the polarizer with that double-headed arrow. Vibrations perpendicular to that are blocked, absorbed by the material. This polarizer is in front of a light table, and the light waves coming at you are wiggling up and down, left and right, and every diagonal direction. Those diagonal vibrations, however, can be thought of as simultaneous vertical and horizontal vibrations. So we can think of the light as having only vertical and horizontal components of vibration. And this polarizer, as it's oriented now, is letting through only the vertical vibrations. If I turn it, however, then the light getting through is now vibrating horizontally. Here's a second polarizer. With the two transmission axes parallel to each other, there's not much difference where they overlap. The first filter, closer to the light source, blocks almost all of the horizontal vibrations and lets through the vertical vibrations. The second one, closer to you, lets almost all the vertical vibration through. It would block horizontal vibrations, but there are no horizontal vibrations hitting it because they were blocked by the first polarizer. Now, if I rotate the foreground polarizer, what will happen? Let's see. The first polarizer blocks the horizontal vibrations. The second blocks the vertical vibrations, so essentially no light gets through. I say essentially because the filters are not 100% perfect. Now I'm going to put a horizontal polarizer on a stand here in the foreground, so I have a hand free to introduce a third polarizer, a small one, in between the first two. Notice that some light gets through when the small polarizer is diagonal, but no light gets through when the small polarizer is either vertical or horizontal. Can you explain why?
Here is a single red dot on a white piece of paper, and here is a piece of calcite crystal placed on top. Notice that the single red dot appears as two separate dots. This is because the two separate polarization components, perpendicular to each other, are refracted in two different directions by the calcite crystal. And this can be shown with this piece of Polaroid. There is one of the rays, one of the images of the red dot. Here's the other. This is called birefringence, or double refraction.